Hello students. Today we will be talking about user-centered design and the best ways to extract the requirements from all the users of the system. The focus today is going to be on the user interface. We'll be using ideas presented by Don Norman, one of the main scientists in this field. Dr. Norman is currently the director of the design lab at University of California in San Diego. He is best known for many books in this field. He is one of the thought leaders of this very important and timely field. Now, I want you to think about the pillars that we discussed in class and how extracting requirements from users requires different types of skills, and especially for the user interface. To design the user interface, you need to understand the psychology of your user. You need to understand the groups of users that you have. And furthermore, you need to understand their preferences in terms of art and colors and shapes and lines and all types of issues like that. Now, in most cases, users don't even know what they like. So, the requirements engineer, who will eventually influence the direction of development for the user interface or the visualization. The engineers will interact with the customer to build surveys, try to understand them, understand their roles and what they do, and what's their intent of using the system to be able to get to your desired answers. Okay, so if a user is placed in a cockpit of a modern airplane or a space shuttle, the inability to perform well would not surprise them or bother them, right? But when a user is using a user interface that they want to interact with every day, if they're using a data visualization, a data analytics dashboard that they use for their daily tasks, and they're having issues with it, it's like having an issue with opening doors in different buildings. Sometimes the door needs to be pulled and people push it. Sometimes it needs to slide and people pull it. These kinds of issues are frustrating to most people. And that's similar to what the user interface or your visual needs to consider. Okay, so when users are interacting with a user interface, they face what Don Norman defined as the two gulfs: the gulf of execution and the gulf of evaluation. In the gulf of execution, users try to figure out how their user interface operates. And the gulf of evaluation is where they try to figure out what happened. The role of the designer is to help people bridge the two gulfs. In the gulf of execution, the user is always asking, how do I work this? And what can I do? What are my limits? What are my powers? And what can I get out of this? However, in the gulf of evaluation, the user is trying to measure and understand what happened, and is this what I wanted? Is this my intended goal from using this data visualization or this interface? So the gulf of evaluation reflects the amount of effort that the person must make to interpret the physical state of a data visualization and to determine how well the expectations and intentions have been met. So the gulfs are present in all interfaces, not only with user interfaces and data visualizations. They're present in our everyday interaction with the physical world. Now, it's very interesting how many people do experience difficulties, but they explain them in different ways. Some say, I blame myself. I'm being stupid. I don't know how to use this thing. Right? And some blame the actual device or the interface or the visualization and say, I need training. I need to learn how to deal with this. So it's different from a person to another, and that's where the human psychology comes in. That's where their psychology affects how they interact with the visualization. Now, when you're trying to extract requirements, when you're trying to meet with your users, understand what type of users they are, their level of technicality, their level of understanding of computers and software systems affects how they would perceive such actions. And it will affect, most importantly, how the engineer will be able to go back to the requirements team and capture these requirements and write them in a way that matches the majority of the users, or that matches the main users of the intended under development visualization. So to summarize the two gulfs, in execution, the user first plans to use a data visualization, they specify what they want, and then they perform. Okay? Now, after they perform, they perceive what's going on. Then they interpret the interaction with the visualization or with the user interface. Then they compare that with their goals. Now, when the requirements engineer is collecting requirements, they need to understand that the user will be comparing the goals with the requirements that he initially provided to the engineering team. Therefore, it's very important to observe the users as they go through this process of the two gulfs. And before they get to their goal, the engineer needs to have a very good understanding of what that goal is. And that's what a good requirements engineer would do. Understand the goal, capture it in a functional or a non-functional requirement, and push that to the requirements document to keep it as one of the main flagpoles of the project. Alright, so to list again the two stages of these two gulfs. The first thing is the user goes through a planning phase. They plan what they want to do with the user interface or with the visualization. Then they specify what they want to do. They go into more details. Then they actually perform with the expectation of reaching their goal. But before they reach their goal, they need to go through the bridge of evaluation. Okay? The bridge of evaluation is what gets you from the visualization to the actual goal, right? And that bridge over the gulf of evaluation has three main steps: perceive, interpret, and compare. So these are the six main parts of execution and evaluation: plan, specify, perform for execution, and perceive, interpret, and compare for evaluation. Okay? So this is a very important point. This touches on two things. One, how should a requirements engineer deal with the user to extract what they want in their visualization. The user, at the end of the day, wants a certain amount of scientific information and data to be present to them in the visualization. And therefore, the engineer needs to capture that and needs to understand what type of data are we talking about, what level, what aggregation level, what type of data formats, what type of language, all those details, what types of graphs and colors and everything. That is captured through the requirements process, that is captured through interviews and surveys done by the requirements team to understand what the eventual visualization needs to look like. Okay? So plan, specify, perform. That's what the user does when they execute. Then perceive, interpret, compare. That's what they do when they evaluate. Alright. So that was the first major idea of this class. The two gulfs of execution and evaluation, and how the engineer needs to perceive them to understand the requirements of the visualization user. Now, some engineers summarize the user interface requirements in a UI requirements document, in an independent UI requirements document, while others put the user interface requirements with the generic or with the one big requirements document that has everything else for the system. And I like the second one more. I don't see a reason why UI or your dashboards or your data visualizations need to be separate from the actual requirements document. But something to think about. They're both acceptable ways of doing it, and that's potentially also part of the job of the program manager or the project manager, where they interact with the customer and see if the customer has a preference, then they'll go with that. Otherwise, it's a strictly technical and maybe a management decision. Now, for example, if you think of the user's perspective about a data visualization, the user thinks that the quality of the data is as good as the quality of the visualization, because that's all they interact with. And I'm talking about non-technical users here. Maybe some technical users will have access to the actual data and they would be able to extract their own sets and do their own analysis through other tools and so on. However, most non-technical users judge the visualization only through the eyes of the interface / visualization. They don't understand the backbone, they don't understand what's behind that visualization, the type of tables and rows and columns behind that visualization. Therefore, it is very important to have a visualization that matches their needs. Now, one can argue that how would I know what are the preferences of my users in terms of colors and in terms of what they want to see and how they want to see it and how do you want to make it organized and so on? Now, there are two parts to the answer to that question. And I'll start with the first one. The first one is using data collection. Okay? Knowing the user requires in-depth studies about the user preferences, designing surveys, and spreading these surveys across the organization and collecting data, observing for a certain amount of time how users interact with these user interfaces. Some tools collect where the users click and on the interface and how they browse through the interface and how they navigate their way towards they want to get. So if the engineering team is able to build tools that can capture these steps, once they build tools, they can collect that kind of data, analyze it, and build the dashboard, build the visualization based on those results. Okay? So collect data for your user preferences and how they would want their visualization to look like. Now, there are methods that we discussed in class like Kanzei engineering. Kanzei engineering is an old Japanese model that was built to evaluate the interaction of workers with machines and their feedback about the locations of certain switches and buttons and all types of parts that they interact with in the machine. This is a method that was highly used in Japan in the early 70s. It widely spread among Japanese companies, and in the 90s actually also spread to the United States. Okay, so I'm not going to go through great detail about Kanzei engineering, but it is based on the notion that physical forms of products play a major role in formulating customers' opinions.